Today, stockpiles of atomic weapons have become so dangerous that people around the world are talking about the need for nuclear disarmament. But the creation and testing of atomic bombs continues to this day. In this video, I will tell you about who invented the nuclear bomb and why. You will learn how the most powerful weapon was created, why it was never used, and at the end I will show you something that you will not see in ordinary physics textbooks: how the most dangerous nuclear bomb in the world works. What is nuclear bomb? Nuclear weapons are, in the old way, atomic weapons, an explosive device that uses nuclear energy, which is released as a result of an avalanche-like nuclear chain reaction of fission and heavy nuclei, and/or thermonuclear fusion of light nuclei. Do you understand something now? Now I'll explain everything. For a long time, it was believed that the most powerful weapons could only be created using explosives. The discoveries of scientists who worked with the smallest particles provided a scientific justification for the fact that with the help of elementary particles, it's possible to generate enormous energy. 1783, discovery of Uranus. Klaproth isolated it from uranium resin and named it after the recently discovered planet, Uranus. As it turned out later, it was in fact not uranium itself, but its oxide. Pure uranium, a silvery white metal, was obtained only in 1842 by Peligot. The new element did not have any remarkable properties and did not attract attention until 1896, when Becquerel discovered the phenomenon of radioactivity of uranium salts. After that, uranium became the object of scientific research and experiments, but still had no practical application. But why? A nuclear charge always attracts attention as an unsurpassed device in terms of power. Boom! When, in the first third of the 20th century, the structure of the atomic nucleus more or less became clear to physicists, they first of all tried to fulfill the old dream of alchemists. They tried to turn one chemical element into another. 1934, scientists were shocked. The French researchers, the spouses Frederick and Irene Joliot-Curie, reported to the French Academy of Sciences about the following experiment. When aluminum plates were bombarded with alpha particles, helium atom nuclei, aluminum atoms turned into phosphorus atoms, but not ordinary, but radioactive, which in turn turned into a stable isotope, silicon. In 1938, the German physicist Otto Hahn and Fritz Strassmann repeated, in general terms, the experience of the researchers, taking uranium instead of aluminum. The result of the experiments were not at all what they expected. Instead of a new super heavy element with a mass number greater than that of uranium, Hahn and Strassmann received light elements from the middle part of the periodic table: barium, krypton, bromine, and some others. The experimenters themselves could not explain the phenomenon they had observed. It was not until the following year that the physicist Lisa Meitner, to whom Hahn reported her difficulties, found a correct explanation for the observed phenomenon, hypothesizing that when uranium was bombarded with neutrons, its nucleus split. Despite the successful advancement of scientists, the country, due to war, constantly experienced difficulties with resources, especially with the supply of heavy water. In the later stages, exploration was slowed down by constant evacuations. On April 23, 1945, the developments of German scientists were captured in Hagerloch and taken to the USA, where the first nuclear bomb was created. The destruction caused by the test stunned the scientists. And I always thought that an atomic bomb, unlike a conventional one, does not explode on accidental impact, especially after falling into water. Looks like it was going to explode. Trinity, with a capacity of 21 kilotons, the Americans experienced the first in the world. During the explosion, the nuclear mushroom rose 11 kilometers. At the site of the explosion, a new mineral was obtained, tritonite, formed as a result of the fusion of quartz and feldspar. The length of the first device, which was used for its intended purpose, is called Little Boy. Its size reached 3 meters, with a diameter of about 70 centimeters and the power of 18 kilotons. Whoa baby, just look at this. During the explosion of the Melosh, a fungus was formed with a height of more than 6 kilometers. It was this kid that wiped out the whole city of Hiroshima, followed by one of the most powerful nuclear bombs in the world, the Fat Man at Nagasaki. The power of the Fat Man exceeded the power of the baby by 3 kilotons. It was the second and last explosion of a nuclear bomb in the history of mankind, used for combat purposes. The most powerful thermonuclear bomb in the world was created in the mid-60s by the Soviet nuclear scientists, led by the academician Khrushchev IV, calling it the Tsar bomb. or AN602. This type of hydrogen bomb involves the use of energy from an uncontrolled nuclear fission reaction, that is, the conversion of light elements into heavier ones. For example, the conversion of 2 heavy hydrogen atoms into 1 helium atom. The device was tested in 1961 at a test site built on the island of Novaya Zemlya. An 8-meter bomb was dropped from a Tu-95M aircraft at an altitude of 10 kilometers. Further, the device transcended by parachute. Having reached the estimated height of 4,000 meters, the charge was activated. The measured power exceeded 58 megatons, a scientific proof of the fact that a thermonuclear bomb cannot be limited in power by anything was obtained. The mushroom cloud has reached 67 kilometers. The double cap characteristic of a thermonuclear bomb has a diameter of 95 kilometers. The effect of a nuclear explosion was felt by people at a distance of 1,000 kilometers. Seismologists have recorded that the shock wave circled the Earth 3 times. By the way, the carrier aircraft for it was made in a single copy. Powerful, of course. There is such a bomb, Mk41, B41. It is considered the most effective thermonuclear weapon ever created. The power is 25 MT and weighs less than 5 tons. This is efficiency. Thank God the main result of the tests is that they have launched negotiations on a worldwide nuclear test ban. More than 100 countries have signed up to this agreement. And finally, we come to the device. What makes these weapons get explosive mushrooms of this magnitude in the composition of the weapon? The principle of operation of a nuclear bomb is based on the chain reaction of the decay of heavy nuclei or thermonuclear fusion of lungs. During these processes, a huge amount of energy is released, which turns the bomb into a weapon of mass destruction. Uranium naturally has a mixture of 3 isotopes: uranium-238, uranium-235, and uranium-234. A nuclear chain reaction is supported only by uranium-235 isotope. However, in the proportion of the uranium-235 isotope in natural uranium in small, and thereby the preparation of the uranium for nuclear weapons usually includes a uranium enrichment step, when the proportion of uranium-235 is increased. Structurally, the first atomic bomb consisted of the following fundamental components: a nuclear charge, an explosive device, and an automated charge detonation system with safety systems. Ballistic case of an air bomb, which housed a nuclear charge and automatic detonation. The atomic charge of the Tsar bomb was a multi-layered structure in which the transition of the active substance, plutonium, to the supercritical state was carried out due to its compression by means of a converging spherical detonation wave in the explosive. Already, the first plutonium parts contained a small amount of impurities and highly active isotopes in the cavity of the plutonium core in a composite shell of natural uranium. A NS neutron fuse was installed. One of the most complex components of the first RDS-1 atomic bomb was an explosive charge made from an alloy of TNT and RDX. The choice of the outer radius of the explosive was determined, on one hand, by the need to obtain a satisfactory energy release, and on the other hand, by the permissible external dimensions of the product and the technological capabilities of production. The explosive charge was structurally a hollow ball and consisted of 2 layers. The inner layer was formed from 2 hemispherical bases made from a domestic alloy of TNT and RDX. The outer layer of RDS-1 explosive charge was assembled from separate elements. This layer, designed to form a spherical converging detonation wave at the base of the explosive and called the focusing system, was one of the main functional units of charge, which largely determined its performance characteristics. Decades later, over decades, the veil of secrecy fell from the first nuclear explosive structures, and the device of the nuclear part of the atomic bombs, Fat Man and Little Boy, became widely known and discussed. The uranium and plutonium elements of these bombs and other components of the nuclear assembly are considered in detail. In particular, a focusing system of special prisms of explosives with different detonation velocities, giving implosion, an explosion with an inward-directed shockwave, as well as the number of detonators, the device and the material of the tamper, pusher, neutron source. And the main secret, by the way, is not at all in the composition, but in the production of pure materials. The isolation of uranium-235, for example, as well as the production of equipment for this production, centrifuges, and other things. Along with the development of nuclear charges, the algorithms for controlling them are also being improved. The capacities of the automation unit and the efficiency of the explosion controlled by them are growing. Which ways the development of these complex devices will go, we will talk about in detail in our next video on What Is. If you want to be aware of the most amazing events, subscribe to my channel. Together, we can create the strongest community of science fans.